Now it's time for our last video dealing with the sum and difference formulas. This time we don't have any new formulas to learn. We're just going to try to apply them when we don't know our angle measurement, but we know information about the sine, the cosine, the tangent, and the quadrants. So yes, you could use arc sine, arc cosine, arc tangent, find some angle measurements and apply them that way. But we're going to think about it more in terms of sides of a triangle and the ratios of the sides of a triangle. So a reminder, these are all your formulas. They are on your identity sheet. If you want to have that next to you, that can help. We have two examples. So the first one says, find the sine of u minus v, given that u and v are in quadrant 2, and we have this information about our two angles. So the first thing that's going to be important is that both of our angles are lying in quadrant 2. So I'm going to go ahead and call this one our purple angle. I'm going to draw an angle in quadrant 2 that has a sine value of 5/13. Keep in mind I drew it proportionally, okay? The 5 should be shorter than the 13, and we know from our right triangle Pythagorean triples that that will be a -12. I'm going to call this one our red angle. V is also in quadrant 2. So I'm going to draw in quadrant 2 with a cosine value of, that one's not very good, let's do that again, of a 3, 4, 5 triangle. So because this is in the second quadrant, I know the negative sign has to go on the x value, and then we'll get a +3 from our Pythagorean triples. Okay, so I've got my angles set up. This would be angle U, and this would be angle V. So now I want to find the sine of U minus V. Well, thinking about our identities and our formulas, we know that the sine of U minus V is going to equal the sine of U times the cosine of V minus cosine of U times the sine of V. I don't have a unit circle to go off this time for all of these values, but I do have these triangles of which I can read from. So this whole thing will be equal to, we want the sine of U, so that's something with our purple angle. The sine is going to be 5/13. Then I want to multiply that with the cosine of V, so that's coming from this second triangle, -4/5, minus the cosine of U is something with the purple angle, so -12/13. Again, I got that -12 from the Pythagorean triples. And the sine of V goes back to our red one, and I'm going to multiply with 3/5. So now for a little bit of fraction work, I'm going to get -20, 5 times 13, 5 times 3 is 15, so we got 65. This is going to turn into plus, 12 times 3 is 36 over 65. -20 plus 36 is going to be 16 over 65. And that's my final answer. I don't think anything goes into both of those. I think we're okay on that front. So the sine of U minus V is 16/65. Now, sine is coming out as a positive value, and if you think about how big angle U is in relation to angle V, if I were to take angle U and subtract from it angle V, I should end up somewhere in this first quadrant, which would make sense then that sine is positive. Alright, next example. Alright, once again we have two different angles. In this case we have X and Y. I'm going to use orange for the X angle and blue for the Y angle. Maybe it's because the Bears game is on tonight. But anyway, this time we're looking for the cosine of X plus Y. So first I need to understand which quadrants my angles lie in. Well, X is somewhere between 0 and 90 degrees, which means that's going to put me in the first quadrant. So I'm going to draw my angle X that has a sine value of 24/25, and we know from our Pythagorean triples this side is going to be 7. If you don't remember that, you can go through and do the Pythagorean theorem and you'll find it just the same. Then thinking about angle Y has to be somewhere in between 90 and 180, so that's going to land me in the second quadrant with the sine value of 3/5. I know my missing side should be 4, but since it's in the second quadrant, this point up here, would need to be -4. We'll call that angle y. So now I'm done with this information and this information. Now I want to focus on actually finding the cosine of x plus y. Well, I know that it's not as simple as just taking the cosine of x and adding it to the cosine of y. We're going to have to use our formulas. So cosine of x plus y is cosine of x times the cosine of y minus sine of x times sine of y. So I'm going to start with the cosine of x is 7/25, and the sine of x is 24/25. I'm just writing that in so I don't have to change colors. Cosine of y is going to be -4/5, and the sine of y is going to be 3/5. Multiplying things together, I'm going to end up with 7 times 4 is -28, all over 125, minus 3 times 24 is 72, all over 125. -28 minus a 72 should give me -100 over 125, which I know will simplify to -4/5. Okay? And again, if you think about it in terms of what's being asked up here, here's angle x, here's angle y. So I want to take angle y and add to it angle x. I don't know if that's going to get me still in the second quadrant or somewhere in the third, right? It might take to here, it might be a little bit farther. But regardless, I'm going to end up with a cosine value, or an x value that's negative. So -4/5 checks out as a reasonable answer. That's it. Just draw your angles and your quadrants. Label your sides using Pythagorean triples or using the Pythagorean theorem to find your missing side length. Be careful that we always draw triangles to the x-axis. Be aware of signs, negative, positive, all of that good stuff. And then just apply your formulas. Keep things color-coded if you need to. It'll help.